This is a demonstration of a application that I've put together to support data professionals to use generative AI to design their data architecture, data modeling, and to perform analysis of this data. And so this is sort of an example of what one can do with generative AI in the world of enterprise data platforms. And I'm providing this with an example data set here. So in this application, the first thing we're going to do is select our generative AI model. So I'm using the OpenAI data AI models here, but we can obviously use any AI model that we can query via an API. So let's select 4.0 here. We're then going to connect to an Apache Spark platform that I've got installed locally, but likewise any data platform that we have network connectivity for that we can run queries on is going to be appropriate for this situation. So here we go, we're connected to that. Now here's our data platform, so the information on that and the tables that are contained within there. And then here's our data models. And so we can build out a catalogue of data models that we could use here, but in this situation what I want to do is to use AI to infer that data model from the tables that exist within the data platform. And we'll just wait a little while the queries run. And here we go. So this is the model that it's then inferred. And we can see, very nice, it's worked out what the relationships are between these tables. All right, so now that we have this model of the data that's in the data platform, we're going to use this model as our active data model to then run queries against this data. So first of all, let's perform some analytic queries. So, first one I think we'd like to do is copying and pasting from over here. We'd ask it to break down the sales of employee by customer. So, and in here essentially what we're doing is we're using the AI to, with this data model, convert this natural language into a SQL query. So, and that's what it's done. And we can now submit this query to the data platform where it's going to execute that. Just running, and here we go, we can see it's given us the breakdown of sales of employees by customers. So we've got our employees and then here's the customers. So this is Syed Abbas and these are all the customers to which they've made sales. So what's some other queries that we might want to do? Okay, so another query I'm going to do is this one here. So what is the name of the employee with the most sales and what was their total number of sales? So let's run this. And here we can see this is the query that's generated, which we can then submit to the platform, and it said, okay, so Gillian Carson is the person and they've performed 7,825 sales. And then finally, let's do one more. Let's ask on what day was sales made to the most different customers. So what day was sales made to the most different customers? And then we can see the query it's doing a count distinct of customers, and it's grouping it by order date, ordering it by the unique customers, and then linear it to 1. So that makes a lot of sense to me. And there we go, and that would be our answer to that. Now there's some other queries we can do. Let's do a free query of this. So let's ask this some information about this data model. So let's ask it, what are the business use cases served by this data model? And also, how can we improve this data model? Question mark. Alright. And so what are we being told now? So again, the time that the queries will take is going to depend on the nature of the model that's one's running. So this is the business use cases. Yeah, it's saying it's a customer relationship management. It's pretty obvious. Sales and order management, kind of things we would expect. And suggestions for improving the data model is we might want to normalise data integrity and consistency. That's all some good advice. Okay, now finally I'd like to show how we go through and construct a star schema using this transactional model. And in this situation, you can see I'm using the ChatGPT 4 Turbo, which is a more powerful model than 4.0, which I find better for the more complex queries of such as constructing a star schema. And so this does give you a good idea about using different models for different purposes, because certain models are going to be cheaper to run in the long term because of the costs of running queries against them. And we can see using also this more powerful model, it's also identifying another relationship in the model, whereas manager is actually a relationship of the employee table with itself. But no less, let's go and let's query this model and let's produce a star schema. So in this situation, the fact table, the information that I want in the fact table is I want the fact table to be a granularity of individual sales. And I want our dimension tables to be date of order, about the date of order. I want it to be about product information, employee information, customer information, and then vendor information, which is the more interesting table because it's not joined directly against what will be our fact table in this model, which is basically the order table. So let's see what's going to happen. This is going to take a little bit longer to get a more powerful model, and it's going to do a bit more processing. So, and I do think this is where AI will be at its most useful for the analysis of transactional models and how we would transform that into a reporting model of various descriptions, be those reporting models star schemas or be it process of flattening out individual tables, which we would then use for perhaps advanced analytics use cases where you might have teams who will be running machine learning and other analysis. So let's have a look. Okay, it's identified the fields in the fact table it's creating, so it's creating a vendor key, it's determining the fields in the dimension table, giving us information about those, how this is joining together. It's giving us SQL to create these new dimension tables, SQL to create the fact table, and then the SQL to populate fact table from the base model. So you can see where it's joining things together, it's doing a bit of complex logic, outputting the complete SQL to populate all the dimension tables. And most of these are just going to be joining those tables directly in this situation. Although in product, it's joining together the subcategories and the different categories information. And in the vendor information, it is inserting into a vendor from vendors. And this is the overall model that was produced for us. So I think that's very nice. So thank you very much. Hope this is useful.